In this video lesson, what I'd like to talk with you about is factoring polynomials and what factors are. Before we get directly into factoring polynomials, I would like to take some time first and just help you understand what factors are, kind of what they physically look like, how they get written, help you understand what they mean in terms of comparing it with the standard form of the polynomials in algebra we've been seeing. What their physical significance is, and then once I've done those things, I'll slowly start to show you how to actually factor a polynomial, different techniques to take a polynomial that you're given on a test or homework problem and reduce it down to its terms in terms of factors. And so what I would like to do is kind of start out by helping you compare a polynomial written in its standard form and one written in terms of factors, and then slowly I'll proceed from there in terms of what the physical significance of factors are, and then last I'll start to talk about actually factoring polynomials. As we saw before, the standard form for a polynomial in algebra, and if it's a polynomial in terms of x, will be something like f of x equals some term a of n subscript n, x to the power of n, a n minus 1, x to the power of n minus 1, etc., right? All the way down to the constant of a0, right? We've seen that. So we know that's the standard form. And so the question is, how do we factor that polynomial? But before we get to that, you would want to ask the question, why would you want to, right? Why are we talking about factoring a polynomial? What is that? What does that mean? What's the physical significance? Well, before I get into that, let me write something else. Let me write another polynomial, call it p of x. So this is a polynomial in terms of x. And let's say I'm going to write it a different way. I'm not going to write it in the standard form. I'm going to write it in terms of three terms multiplied by each other. And since p of x is only a function of x, we know each term is only a function of x. But that doesn't mean it can have other stuff. It can have constants, or it can be divided by something, as long as the only variables are x. So let's just randomly pick something. Let's say first term is x plus 3. Let's say the second term is x minus 5. And let's say the last term is x plus 1. Okay, so we have a p of x polynomial, only a function of x, three terms multiplied by each other. And first I would like to draw your attention to something. I'd like to point out to you that in one of the other video lessons where we talked about multiplying, how to multiply polynomials with each other, that's all we're doing here. These, what I've been calling terms, you could think of as three small separate polynomials, all in terms of x, where each is to the power of 1, right? Highest power is 1 because they each only have x. The coefficient of each x just happens to be 1. Didn't have to be. I could put a 3 here, or a 2 there, or a 7 there. And it just happens that of course, like here, the a0, here a0 is 1, here a0 is -5, here a0 is 3. So I just want to draw your attention to that is the same thing as multiplying three separate polynomials, right? And we're allowed to do that. We have said p of x is only a function of x. We didn't say how we came up with p of x. Well, now we've indicated we're coming up with p of x by multiplying three smaller polynomials. And usually you think in terms of polynomials being to some higher power. Doesn't have to be. They can all be to just the highest power of 1. They don't have to have some other coefficient a of n. A of n can all be 1 for each x, and that's what we've done here. So see, it starts to piece together if you watch the other video again and kind of think about that. So we've referred to these as three terms. Now I've kind of referred to them as three smaller polynomials that I've multiplied together to make up a larger p of x. Well, now I'm going to refer to these as factors. And I won't get into this lesson of how to actually find the factors. I'll simply in a very backwards way, point out to you that we've already written this in its factored form. But before I explain what I mean by that, I'm going to explain to you what the physical significance of factors is and why people in algebra want to find the factors. Usually when you have some polynomial of x, you want to work with it in some way. And a lot of times in algebra, you would like to be able to graph something. And usually what that means is you will have some coordinate system where a lot of people refer to it as a Cartesian coordinate system, where you've decided to divide up in certain units, just like you would divide up a pizza pie, or if you were going to mow the grass, you were going to divide it up into sections to go back and forth across the finish. It's the same thing. We have this area, this larger rectangular area. We've divided it up in little pieces, and we've indicated two directions. There's the x direction and the y direction. And usually when you're trying to measure something, it's nice to have something to refer against, and usually 0 comes up a lot, right? So this little dot here, a lot of times you'll see it written xy like this, and the dot in the middle where the two cross is usually taken as 0, 0. So here, x is 0, y is 0, we'll say. Well, all this is, these three things you're seeing here that I've referred to as terms and factors, is later on we'll actually show the physical significance of p of x and f of x on plots, how you can actually plot it. And what you'll see is these terms have the physical significance in that these factors, you'll also hear them referred to as zeros or finding the zero. And what people mean by that is each of these terms indicate where p of x crosses the x-axis. So let's say p of x was some strange looking polynomial curve like that, right? Well, the exact shape of it we don't know yet. Just from looking at it briefly, we don't know the exact shape. But what we do know from just looking at these three terms, these three zeros, is we can tell people exactly where this polynomial's curve crosses the x-axis. And where it does is where each of these are 0. Well, if I take this by itself, where would this term be 0? Well, if x was -3. So I'll just write a -3 into there. If I take this term by itself, where would this be 0? Where x was 5. And if I take this term by itself, where would that be 0? If x was -1. So just by doing this brief analysis of these terms, I can tell you, and please ignore the shape of this curve, I didn't mean any exact significance of that, I was just drawing the general shape. But what I do want you to understand is that we can say, we don't know exactly what the curve looks like yet, but we know this. We know that this polynomial x crosses this x-axis at -3, x -3, which is about here, x of 5, 1, 2, 3, 4, 5, so it's one more out here. I didn't draw far enough, so I should have drew one more grid line. And x of -1, which is here. So here, here, and here, we know it crosses the x-axis. And that is the significance of the factored form of a polynomial. That's why people are interested in factoring polynomials. That's what people mean when they say finding the factors or finding the zeros, more importantly. When they say find the zeros, they're wanting you to find where p of x crosses the x-axis if it's in terms of x. And I'll get into, in the next videos, helping you learn how to actually factor polynomials yourself, how to correctly plot it, and things of that nature. But I just wanted to help you get started by this explanation.